Hi guys, my name is Sajay Prakash, and today I'll be talking about a physics problem that might seem relatively obvious at first, but it can turn out to be quite confusing, and I hope that I can help you. So the problem says that three baseballs are thrown from the top of a cliff along with pads A, B, and C. If their initial speeds are the same and air resistance is negligible, the ball that strikes the ground below with the greatest speed will follow path A, B, or C. Now, this problem might seem really obvious to you at first. If you were anything like me, you would probably say that it's A because it goes higher than the others, so it has more time to gather speed and hit the ground. But unfortunately, that's not the case here. The answer is that all of them hit the ground with the same speed. And that might seem counterintuitive, but I'll try to explain it using math. And I think that's the best way. It really makes everything clear, and it really helped me a lot in understanding this problem. So we'll talk about this problem in terms of energy because using energy will help us relate to speed. So the formula for initial total energy is mgh plus 1 half mv squared, and mgh is mass times gravity times height, which is potential energy, and 1 half mv squared is the kinetic energy. It's 1 half times mass times the velocity squared. And obviously the initial velocity here is zero, so the initial kinetic energy turns out to be zero. So we might as well have said it's just mgh, but I thought it better to include the whole formula. Now, the initial kinetic and potential energy is the same for all the balls because they're thrown from the same height, gravity is the same in all the cases, and they're of the same mass. So all of this energy becomes kinetic energy at impact, and none of it is lost because air friction can be ignored. Since kinetic energy is directly related to speed, remember, 1 half times mass times velocity, it can be assumed that for equal masses, equal kinetic energies means equal speeds. And that's why it doesn't matter how high it goes because the maximum height is never accounted for in the equation. So thank you for listening, and I hope that helped your understanding.